Welcome. Let's try to solve another Leetcode problem. 1514, paths with maximum probability. So we are giving a graph. So the nodes gonna be starting from 0 to n-1. So for this example, we have 3 nodes, and we are also having the edges array. So the edges array is just means an undirected graph. For example, 0 to 1, and the success probability, it means the probability of each edge. So for example, from 0 to 1, the probability is 0.5. And 1 to 2, the probability is also 0.5. 0 to 2, the probability is 0.2. And let's check the return. So we're going to return if there's no path from start to end. So for example, 1 to 2, there's no path from start to end. We're going to return 0. Yeah, let's check the return. So where is the return? Undirected graph, probability, giving start and end. Yeah, we need to find the path with the maximum probability. So the return is going to be the maximum probability of success to go from start to end. Yeah. So for example, 0 to 2, 0 to 2, the probability is 0.2, but there is a bigger one. So the bigger one going to be 0.5 times 0.5. It's going to be 0.25. So this is going to be the maximum. Yeah. So we need to return this value. So we can turn this problem into a shortest path problem. So for example, if we turn the values into the negative, for example, negative 0.2, and this one gonna be negative 0.25. Yeah, and then we can use the shortest path. So the shortest path from 0 to 2 gonna be this negative 0.25, because negative 0.25 is less than negative 0.2. Yeah, so we can use this way to solve the problem. Now, let's try to use Dijkstra's algorithm to solve the problem. But we need to turn this graph into a negative graph. Yeah, I mean the values into a negative. Yeah, let's define the graph. It's going to be the default dict, and it's going to be the list, and then for for UV and C, I'm going to use a zip with the edges and the success probability. Yeah, so it's inside of zip, but we can put the positive values, positive probabilities inside the graph. Yeah, currently we're gonna put all positive values inside the graph, but later on we're gonna define the start node, the probability of the start node to be a negative 1. Yeah, if we put a negative 1, it means the negative 1 times all other values will be negative. So we can turn the problem into this, because this is going to be easier. So let me just finish the graph. So GU should append with this V and C, and similarly GV should append with U and C. Yeah. Now let's prepare the priority queue. So inside we're gonna have a cost. So as I said before, I'm gonna prepare the cost to be -1, because if I put a 1, we didn't turn the edge to negative values. If we use a -1, it means -1 times all other values will be negative. So we're gonna use a -1 as the initial cost, and then we're gonna use the start node. Yeah, and then we're gonna prepare the distance array, and gonna be the infinity times the number of nodes, and the dist with the start node would be equal to the first one. Yeah, so the start node would also be the negative 1. So if we are starting from this 0, so from here it's going to be the negative 1. If 0 to 2, negative -1 times 0.2, it's going to be minus 0.2. But here it's going to be the minus 0.25. So this is why we're going to prepare the start node to be the -1. And similarly, And similarly, we're gonna put the cost from the start of the cost to be -1, because -1 gonna be the smallest possible values. Maybe other values may be -0.99, but this one -1 gonna be the smallest values. So we're gonna prepare this smallest values first. Yeah, let me check if it can be the -1 or it can be 0. Yeah, but let me just start coding. So while PQ, I'm gonna pop out the cost with X node. Would it be the heap pop? So I'm gonna heap pop the priority queue. Now I have a cost and X. Yeah. For most of the time, I'm gonna check this C if C is more than X, but here it is a negative value, so I need to check if C less than distance of X. So I will continue. Yeah. So if all the ads are positive values, if I gonna calculate the sorted path, normally C should be more than. But here, as the distance X is a negative value and this C is also a negative value, so I'm gonna use a less than distance array. Yeah, distance X. And then for Y and cost in GX, so I'm gonna have a distance. So this distance gonna be the distance X times the current cost. So the cost would be a probability. So if D less than the distance Y, so I'm gonna update this distance Y to be D. And similarly, I'm gonna push the tuple, push the node into my priority queue. So it's gonna be a tuple with the cost. So the cost would be D and the node would be Y. And finally, if I didn't find the answer, I'm gonna return 0. If I find the answer, I'm gonna have a check. So if this X equal to the end node, so it means I've found an answer. So I'm gonna return this cost. So this cost is a probability, but currently this cost is a negative value. I need to return a positive value, so I need to use -C. Yeah. Now let me check if everything is okay. So the only confusion is about this one. So my distance array. So inside of the distance array, I'm gonna have a initial cost. It's gonna be -1. And similarly, for the priority queue from the beginning, I'm gonna have a cost of -1. So this means currently this cost would be -1. Yeah, this cost would be so this cost would be -1. And then I'm gonna check and use this one to check if a value is bigger than that. Yeah, so if so from here I'm gonna check a value if the value is smaller than that. Then I'm gonna update the distance array. Yeah, now let me run it to check if it works. Yeah, so here the integer and list. So this value should be -1. It's not an array. Let me run it again. Yeah, as you can see, it works. Now let me submit it to check if it can pass all the testing cases. Yeah, as you can see, it works and it's pretty fast. So I think the only difficult part is about this one. How should we prepare the priority queue, the initial cost? So the initial cost, if it is a sorted path, if it is not a probability problem, if it is the sorted path, so from the beginning, we're going to have a cost at 0 because 0 will plus all other values. But for this problem, we're going to use the multiplication. We're going to use the times. So we're gonna prepare a negative value. So the -1 gonna times all other values. And for the initial node, if it is starting, for example, from 0, from the beginning, for other sorted paths, we're gonna prepare a 0. But for our problem, we're gonna prepare a minimum value, and gonna be minus 1, and all other values will be bigger than this value. So this is why we're gonna prepare minus 1. But what about if we calculate the start and add to be 0 and 0, for example 0 and 0, so the result would be 0 because there's no adds, because the start adds is 0, the end adds is also 0. What's gonna happen? So yeah, so we put a 0 and this is minus 1, and we can check it directly from here. Yeah, so if this x equal to 0, because this add node is 0, we're gonna return a minus c. So this minus c becomes 1. If it is 0 and 0, so the probability gonna be 1, because we don't need to go through any adds. So this is just other examples. I'm not sure if we will have this kind of testing case. So if we are going to calculate from 0 to 0, the result gonna be 1. Yeah, because from here it is minus 1, and then we're gonna return minus 1, and it's gonna be 1. Yeah, I'm not sure if we are having such testing cases, but I think that is enough for today's problem. Thank you for watching. See you next time.